Welcome back to the stream, folks. You may have had your first introduction there thanks to the jackhammer. The theme of today's stream is going to be working on the cat tracking code a little bit while trying not to melt the CPU on this machine. I've actually got a bigger CPU cooler arriving at some point today, but right now it's going to run a little warm, but it's doing its best to track Tuco. And in fact, the debug interface has something new in store. Let's see if we can just get that full screen. This is the current state-of-the-art cat tracking. It's not currently moving around. The robot is just hanging from a stationary stand, but the gimbal has the ability to swing around. It has a limited range, it doesn't move continuously. So if you see that angle tracker at the top, you also see that orange rectangle is when I'm moving it around manually. But then if I just leave it alone, then it will try to keep its eye on Tuco. And we had been viewing these kind of bouncy, debuggy sort of rectangles before, and that was an accurate reflection of the output of the computer vision algorithm, so they were super useful for debugging, but they were a little tiring to look at because they moved around so much. So this is my my idea for how we could have a slightly less annoying visualization, little cat sprites. And so yeah, I just have a bunch of sliders where we can change the opacity and all that. And the particular sprite is in the same texture that holds the font for all the debugging stuff. Because in fact, everything that's being rendered on the stream by the plugin. So not like the little logo in the corner that's being cut off right now, but like all the text and the rectangles and the cat sprites are all rendered using the same texture, and they're just all rectangles in a vertex buffer. So then the Rust code implements a little particle system that follows the outlines of the rectangle. So as the rectangle bounces around, it just ends up pushing around the cat sprites, which are a little bouncy to begin with. Oh, there was actually a bug in the cat sprite code where there's a little bit of unintentional random jitter that gets applied to each one because they're actually colliding with themselves. And I haven't gotten around to fixing that, I think. But it has the unintentional side effect of adding some random bounce. So I'll actually probably want to preserve that in the form of a different parameter that's actually intentional. And so, in case you're wondering what kind of system this runs on, I haven't talked about that before. So the robot itself has a tether, so all the computing can be ground-based. So it's actually just running on like a big old desktop PC. It's actually in a 4U case in the equipment rack over there. And so this is the actually top of the to-do list right now is the tracking. The way, like the whole control loop between this rectangle and the gimbal positions needs overhauling. This is the second iteration, and it still sucks. The first iteration was just a really simple proportional control loop so that it would look at the center of the rectangle versus the center of the screen, multiply that by a gain, and that was the speed that it tried to move the gimbal at. And then the main problem I had with that is that it had no concept of hysteresis. There was no like acceptable region where you could just like watch something move around and keep it stable without reacting to every little movement. Oh yeah, Alistair says replace the cats with birds and it'll look like Tuco's run into a wall. Yeah, they look a lot like those computer or cartoon birds. Oh, we're hitting the end stop. That's cool. Yeah, the camera's not in a very convenient place right now. I wonder if I can put the camera somewhere further away where Tuco won't bother it and it'll have a wider view. That might be better. Especially if I put it back there. don't think it'll be able to see Tuco right where he is now, but this cable out of the way. Yeah, right now the gains are painfully slow. The gimbal can move a lot faster than this. I just don't have the controls necessary to keep it in control, moving faster. And the gains are just set arbitrarily slow right now. Yeah, now it's hitting up against the downward end stop. It's really interesting how the cats keep getting, like, sometimes there's a bimodal distribution there where, or, you know, multiple modes where the rectangle will actually keep snapping back and forth between different ways of detecting Tuco. So for example here, sometimes it detects his tail and sometimes it doesn't. And so I was just noticing some of the cat sprites getting diverted around his body while some of them tried to follow around his tail. Oh, and this way you can see how the sprites squish up against obstacles. Yeah, so, I mean, this may not be the final form that it takes. We might also want some vignetting too, so there's a way of sort of dimming stuff that isn't in the focus, but I think this is a good starting point. That better? It's still right up against its lower, like its y-axis end stop. This is the cable for the robot camera. Currently the cable is slightly in the way. One of the steps we could do at any time now actually is to kind of suspend the cable from the ceiling. I finally got a little tiny desk, which is actually maybe a stool from IKEA to put coffee cups and stuff on, and it's at a lower level than any of the electronics here, so I can't spill coffee on the equipment. I mean, I could spill it on the floor. If I'm really unlucky, I could like chuck the coffee directly into a power strip or something, but that's about the worst I'd get. And that would like maybe throw a circuit breaker or make some terrible sizzling noise, but it wouldn't destroy an expensive instrument. Oh, this is nice. I'm not controlling it at all right now. This is all automatic. Hey, Tuke. So this is a little earlier in the morning than I usually stream, and now you're seeing all the spots where the sunlight directly hits this desk. Anyway, so yeah, there are a couple things on the to-do list. I'm really anxious, I'm sure all of us are anxious to see this thing actually zooming around the room. So one thing we could just devote some time to pretty much any time is actually building the rest of the winches and getting the winches set up, and then we can start experimenting with code to move the robot around physically. So that's really cool. I think one thing I want to try doing before that is actually just get this tracking algorithm working a little better. So I think for that, the current scheme, so I already described the original scheme where it was looking at the center of the tracking rectangle versus the center of the camera and then multiplying that by a gain. And that was bad because it had no concept of this is close enough, don't move. So you ended up just responding to every tiny movement with a bunch of jitter, which wasn't nice. And it also had trouble responding to both fast movements and being stable in all conditions. So it was difficult to tune and didn't really work very well. So then I tried a different approach, which was just kind of a hunch, which turns out to, I think, have been just a bad idea. And that's what it's doing right now. I'm defining the... So I guess the concept that's directing some of these changes is that I want to be able to define regions of the screen that when the tracking rectangle is starting to get outside the center by a certain amount, it will apply some gain. And the reasoning behind this is I want to have at least 3 different regions where if the tracking rectangle is close enough to the center, it doesn't do anything, or it only does drift compensation effectively. Then if it gets into the first region, it sort of softly moves. Then if it gets close enough to the edge, then it starts actually moving fast enough that it hopes to keep the thing tracked as it's moving out, trying to move out of frame. So, where is Tuco anyway, speaking of tracked? Oh, he is right under my chair. He's got a bolt. Yeah, it's not going to keep up with him right now. Yeah, this is pretty fun. Can I manually find him? Currently, I can't point the gimbal down very far because the control loop in the gimbal gets unstable beyond a certain point. And that's also something we might be able to improve by tuning the parameters in the gimbal. That's an option that's very available to us. It just needs doing. Oh, I think Tuco is down. Oh, here he is. Good job, boy. Yeah. So the current strategy overlaps that rectangle with some rectangles at the edges of the screen that define gain regions. And so each rectangle has a, like XY width height, and it has a 2-component vector which describes what nudge we should give the gimbal. And so all it's doing is overlapping those rectangles. It's taking the intersection of them, then taking the area of the intersection and multiplying it by the gain. And I mean, it kind of sort of does the right thing, but it scales completely wrong because it turns out you don't actually want like quadratically more gain when the object is that much larger in the frame. So I want to change it so that it, first of all, is kind of a 1-dimensional metric rather than a 2-dimensional. We're looking at how far into that region the rectangle pokes. So for example, if we're looking at the top of the screen, I'd want to be able to define a horizontal line, and then as the rectangle extends past that horizontal line, we're just looking at the height of that region above that extent, and it doesn't matter how wide the rectangle is. I thought that it might be good to control for that, but I've reconsidered my opinion on that. And so because I think before I was worried a lot about kind of out of control rectangle sizes, but that's something else that hasn't really been a thing since disabling the automatic scale tracking in the tracking algorithm, which I disabled to save CPU because it was just way too CPU hungry. But without the scale tracking, the rectangle size is always either the size of an actual object that was detected in the scene, or maybe like a phantom object, but the object detector said it was pretty real. And, or it's the default size that we have for manual moves. So like when I move this manually, it just resets it to the default size, because that's what seemed best after trying a couple things. It sounds like Tuco's eating. I think he's just behind this other stuff so we can't see him. Sometimes the computer vision thinks that that rat toy is Tuco. Well, is a cat, really. Yeah, the circling of cats definitely reminds a lot of people of the old like kind of cartoon dizziness effect, which maybe we could use that a little more. I don't know. I feel like the cat sprites are kind of funny, but they don't really make a lot of sense, and that I kind of like the particle swarm effect, but Yeah, maybe there's some ways to tweak this to make it better. I think it's better than what we had before for sure. Yeah, so I guess maybe the first thing, I should write down these particle effect changes, because like while we're talking about that, there were a couple of things that were just flat out bugs here. There was the collision bug / random walk implementation. Is there anything else to do with that? I mean, we could try changing the sprite, but I think that's well worth saving for later. I think I just want to fix the bugs there. Yeah, anyway, I think the main thing we want to work on is that kind of gimbal gain thing. So, in fact, I do still like the idea of keeping several distinct regions, but I think I want to, instead of having them just be like rectangles, because the two-dimensionality of it I think is just wrong. I think I actually just want them to be lists of one-dimensional gains, and then I'll just have a list for the x-axis and a list for the y-axis. Just realizing I can't see the Twitch chat. Sorry, folks have been trying to talk to me there. Oh, how do you even see the Twitch chat when the window is so narrow? I guess, I don't know, maybe someone who's better at Twitch can tell me, but it seems like the chat only loads once your window gets beyond a certain width. And so I've got this like tiny monitor over here that I try to use for both the Twitch and the YouTube chat. And if I try to just split the vertical evenly, then YouTube works. I can just scroll horizontally, but Twitch actually just hides the chat completely, so I actually just have to make the window wider. That's annoying. Oh, that's Sean in YouTube chat suggests halos or devil's horn sprites for good or bad kitty. Oh, that would be funny. I mean, if we had more information about, you know, kind of metadata about the cat from the object detector when the cat was last detected by the neural net, that would certainly be a thing. Is Tuco still in the kitchen? Oh no, he's actually way over here. We just completely lost track of him. He is really good at sitting in the camera's blind spot. Oh, you might be able to barely see him. He is really good at that. Oh, I think the chat might be hung while I'm fussing with random stuff. Oh, right, as it's bouncing there, it's also reminding me that the edge, the limiting algorithm at the edge needs work. Okay, so gain and limiting are two things we should work on. That's I think kind of my current list of things that I want to do in the software before really focusing on the winches, just to get this to be a little bit less constantly frustrating. So just fixing some cat sprite bugs and both of the sources of gimbal movement right now, the edge limiter and the gain. I added a drift compensator. It's completely manual right now. It just has two little sliders you can use to just like fine adjust the zeros for the x and y velocity. And I should certainly try to do better, but it's better than nothing. Where is Tuco? I think he's over there behind the cables. I think he's hunting for bolts. Anyway, let's see how warm the computer is. It's pretty warm. It's not quite as warm as it was getting yesterday, but yeah, it's gonna be nice having that extra heatsink. Like, yeah, see, the air in the computer is not even getting that warm. The GPU seems fine. It just seems to like running about that temperature. It just like doesn't even turn on the fans until it gets about that hot. But then the CPU is running hotter than it likes. All right, well, that seems like a good excuse to close this. Of course it crashes on exit. I still have a crash bug. Oh no. Yeah, sorry about the momentary chat broken. Hey, Tuco. Oh, of course, now I can't. Well, I can still aim manually, it just the computer vision doesn't work with OBS closed. Whoa, thanks, Tuco. Yeah, I can't trust it to stay focused on the cat without the... Or I can't trust it to stay anywhere. I mean, without OBS, the Rust process will understand end stops, but it doesn't understand keeping the cat in frame. Oh yeah, the hardware monitor has a lot of data for this machine. That's pretty cool. And the gimbal's just drifting. You know, the CPU is probably fine for a little while. Let me just try running OBS again. We can leave it running while we're hacking on the code just so that it can track Tuco. It hasn't actually seen him yet, though. Hey, Tuco, can I make some room for you? Oh, now it has. Cool. Yeah. That's better. Okay. Well, that'll do for a bit. Let's open a text editor along with all this other junk. Watch my CPU melt down. Actually, it turns out that... So I was shopping for CPU coolers, and... yeah, it's just like amazing how large of a fan you can still fit in a modern CPU or a modern computer case. Luckily, this is a 4U rack, so it's about the same size as a desktop. All right, particles. That's right, the collision bug. So I stuck that in this overlay file. Whoa, this font might be slightly too big. Just slightly, okay. Oh man, good old little cat sprites. I was about to say, let's just also stream this, but now I'm just asking for the CPU to melt. So maybe I will stick to 1H.264 encoding. Those are happening on the GPU, but it still seems to be enough extra CPU load that it would raise the temperature at the moment. Yeah. It's cool how the hard disks have airflow temperature monitoring. Currently that seems to be the same as the disk chassis, which leads me to believe that it's not really that well isolated. But the SSD seems to be the coolest part of the system, because it's not got any moving parts or significant power consumption usually. So the particle system currently is just entirely on the CPU, which might be a little silly considering how much spare GPU horsepower we have at the moment. But currently I'm doing all the overlay rendering using the same method where I just send rectangles over the WebSocket. And so I just wanted something I could implement pretty easily without inventing a completely new graphics abstraction. So that's why they're on the CPU. So I have this little object in Rust. You create a particle drawing, you can tell them to follow a rectangle, and they just pull a bunch of other stuff out of the config structure. And you can tell them to render, and they draw to the drawing context, which is this thing that is the abstraction layer around a rectangle accumulator. So the drawing context mostly has a way to store rectangles and a list of current graphic state. And it's mostly getting used for text right now. The text stuff makes heavy use of this BM font crate for Rust, which is pretty nice. It can read the file format that the BM font carving utility creates. And so you just include that binary in your Rust app, and then this will parse that, and you can give it a Unicode string, and it'll also parse that and figure out where all the glyphs are, figure out all the character advancement, and then just return you a list of rectangles. And then I can turn that pretty trivially into the rectangles that the client knows how to draw. So collision detection right now is pretty naive. It's just nested loops, no acceleration structure. I'm assuming that the number of particles is pretty small. One way to algorithmically improve the speed of this, for example, would be to calculate a bounding box. So like the problem here is like you're running through the list of particles, and then for every time you iterate over each particle, you're also running over the whole list of particles because you're seeing which other particles collide. And it's doing, oh geez, this isn't even the non-square root length function. So this is taking a bunch of unnecessary square roots too. I should maybe fix that. Yeah, let's do that. So the other thing I wanted to do is this is iterating over that full matrix of like every particle, every other particle. There are lots of ways to speed this up with a data structure that you record the particles' positions in, and then use that to figure out which particles could be close by. Because the number of particles here is pretty small, and we're just doing this at interactive frame rates, and it's not using much CPU, I'm probably going to put that off and keep this simple. But we can at least make this maybe a little bit nicer while also solving the bug by, instead of iterating over that full matrix, just iterating over like one diagonal half of it. And then we can just take, for example, iterate over all the particles like 0 through n-1. And then for each of those particles, iterate over all the particles like after it in the array, or all the particles before it in the array. And then you end up iterating over just that half square into the full square. And then it's easy to exclude the self intersections that we were having trouble with. And then that can just be a separate step. One thing I would want to do if I did that is that then I would want this to actually push both particles. That would just involve a slight refactor where right now I just update the particle position once down here. And that would actually maybe be a reason to split this so that there's one loop that does the what is this? The perpendicular and particle edge gains, and then another loop that does the collisions. So and maybe just for clarity, I can split this up into a couple of functions, and then the names will be self-explanatory. So this is just either deleting particles or adding particles in case the number of particles has been changed, which it can because the config is changeable at runtime. And this does need the config reference. See, like I could have left that loop in there and like just added a comment, but pulling it out into a function that has a reasonable name seems a lot more readable to me. That camera can just barely see Tuco. Let me see if I can give it a better angle. Ah, that's tricky. And now the camera's blurry. Great. I need to make that bigger so I can see it to focus. Is that kind of in focus? That seems kind of in focus. That's nice. So like my intended use for this camera is that it will probably usually be kind of far away and using the maximum zoom setting. I've just been, changing it from that for the sake of testing and having it be closer to my desk. Because right now it's a little inconvenient given that I can't fly it around the room arbitrarily yet, but that's coming up pretty soon. That'll be nice. Yep, it's a warm computer. So then we'll have one loop that does collisions. And then the rest of this will actually be just related to the rectangle, so maybe it can stay inside follow rect. Hey, Tuco. It's nice just being able to give it a nudge every so often and then having it usually track Tuco. And hopefully it gets better than that pretty quickly. So I'm going to carve this into 2 pieces. There could even be a separate step for velocity and damping. Let's just do this in a bunch of dumb steps. Like this is not how you would write a real physics engine, but this is good enough for a really simple animation. Love collisions. Dynamics, and the follow rectangle. what's that? So this is calculating two forces on the particle, one that pushes it toward the nearest edge, and then one that just goes in this perpendicular direction. Oh, and I also wanted to make that slider go positive and negative. And this is doing damping. This doesn't need to be separate now. All right, now collisions. All right, update dynamics is a good place to put that random wobble that I wanted to add. Let's add that. Okay, then added it to the config and the config editor. Let's make a separate little utility for getting a random vector. I kind of like this having a range of plus 0.5 to minus 0.5. I'm just not really quite sure how to name this to communicate that. It's a unit square centered on 0. Centered square. Nobody will know what that means. Sure, let's just get hopelessly verbose. I think that seems alright. Because I've wanted this same thing in several places, so let's just put it here. In fact, that might even be a good thing to put in vecmath, but I hesitate to put something with thread RNG in such a central place in the code. It seems more like something we would want to centralize or to keep here, because this is like for drawing. It's just for special effects. It doesn't affect the way the bot works. Okay, we'll clean that up. I'm pre-squaring that so I don't have to take the square root for every comparison. So I don't have to square root these until I'm actually going to make a motion based on the collision. Because square roots are really slow. I mean, not slow like memory or hard disk, but still pretty slow. And this is an inner loop. We want the unsquared version of this too. Yeah, that's looking better. You know, now that I have the random motion elsewhere, the reason I added this was so that if all the particles just like reinitialize to the same point for some reason, then they would push apart, they wouldn't just sit there. But we've got the separate random motion, so I'm just going to remove this case entirely. Oops. And so now instead of accumulating this, we're actually going to apply it to both the particles right here. We could have an accumulator for P, but I don't think it really matters. I mean, CPUs have a cache. Hey, Tuco. Yeah, so that seems more like what we want. Let's see if that compiles. Anything else on the list? Random walk, collision bug. That's it for the sprites. Oh, it's gonna catch up with him in a sec. Oh, nice. Oh, square len. Yeah, sure. All right. Let's race the compiler against the gimbal. Yep, yep. New fan is gonna be good. Alright, so what's next? Oh, so I was talking about how the new gain controller will work a little bit, where right now it has these rectangles where when the computer vision rectangle overlaps a gain rectangle, it applies a force to the gimbal. And I want to replace that with something one-dimensional so that the size of the rectangle doesn't matter so much as the amount to which it's exceeding the limit that I set. And I think that'll be good. I haven't quite decided what to do with the limiter yet. Right now it just has a proportional control loop where if the gimbal is past any of its limits, it applies a proportional control velocity in the opposite direction. But the result is that that's super bouncy right now, and maybe I just need to turn the gains down and move the limits in a little bit. Yeah, that might just be a matter of tuning, actually, so that might be worth looking into. See, this is just the gyro having a static velocity vector, which might have not been 0. It might have been like a small non-zero number. So it's some combination of a small non-zero velocity vector probably, plus the gyro drift, and it just eventually goes off in some direction. Oh wow, bagels. Bagels would be amazing. I should go get a bagel. Maybe I should just set a CPU temperature that above which I will just end the stream and get a bagel. For anyone who's missing context, I ordered a new CPU cooler for this machine. It should be in at some point today. I just didn't wait for it before starting the stream. And it's been like this for a little while, like when I run both the OBS instances at the same time. I just apparently didn't notice it because none of the built-in OS tools actually show CPU temperature, and I only went out looking for hardware monitoring stuff when I started trying to figure out how much of the GPU load this was. And it turns out the GPU is totally fine with running under this much power, but the CPU apparently needs a little more cooling, so now I know. But yeah, then when I saw that, it was like, is it supposed to run that hot? And I tried a different temperature monitoring program, and it gave me different results. Two side-by-side programs running were giving me different results by several degrees, but they were both hot enough to be concerning, so maybe they were using different calibration tables or different sensors. Alright, well, hello, gimbal. Now the question we're all asking is, where is Tuco? Here we go. Alright, maybe while we've got this thing running, let's try the bouncy end stops. So for example, it might be that we're going to have a hard time even hitting the end stops that much. I should just turn up the overall gain so we can... It's not going to be very stable, but we can experiment. Oh, this random motion gain doesn't need to be positive and negative. That's an oversight. Let's change that. Negative random numbers are not really useful right here. Oh. Did I get it stuck now that the current value is negative? No, it's just stuck in general, like the name or something is... Do these... Oh, or I'm not authenticated. Right. I think I lose my authentication sometimes when there's also another browser tab open with a different key. And then that other instance sets it in local storage. I should probably make some change that timestamps the keys and only uses the most recent one. Oh, and that's the wrong version, right. Let's just close this and restart this. I think that's the easiest solution. Cool. Authenticated. I think that could go higher. I mean, this isn't like frequency limited, so it might be jittering fast enough that it doesn't really have that much of a noticeable effect. But let's just try changing the range on there. Yeah, I mean, they're just like occasional wild perturbations when I set that really high. But I think in general that won't be really noticeable, and it's just something that I want to keep small just to add a little bit of randomness. And then it looks like the collision stuff is still working. Yeah, that seems right. Cool, that'll be an easy check-in. Alright, now tracking gains. Alright, so I'm going to turn this up. Whoa. Oh yeah, there's some good oscillation. So that is going out of the... that's going past the end stop and then hitting the limiter. And then the limiter is oscillating. Same thing with that limiter. So let's turn the limiter gain down. I'm kind of nervous about going really fast and then slamming into the end stop. I feel like that's how you shear off parts of the motor. And it shouldn't be hitting mechanical end stops. I should just be relying on the software end stops here. So that's an angular rate of like 300. Let's try just changing the max to be way lower. I think I didn't have the units for this right, so the slider is way too high. Let's fix that. I'll summon that to like 100 and see what that does. That's a bit more tame. Oh, and this is a different bug. Now I'm stuck below the end stop. How is that a thing? Maybe this is a good thing to investigate, actually, because this could point toward a reason for excessive bounciness. So that angle is minus 403, and I think the limit is, well, you can see the limit right over here is minus 400. And are we stuck because of the drift compensation? I don't think the drift compensation is doing anything. Limiter gain. Yeah, see, we couldn't actually get back above that until... It was almost like maybe that was a localized area where the gyro drift was, or like some nonlinearity in the system was especially bad and we had to get past that. I mean, there could be some other bug, but that looks like a nonlinearity in the response of the gimbal. So, yeah, it might not be just a matter of tweaking the gains, because you go too low and you get stuck because you can't overcome whatever that nonlinearity or whatever it is. You go too high and you just bounce. So, I think part of the solution here is to make the limiter soft. Whoa. When the computer vision finds Tuco, it just like snaps over. Doesn't it quite see him? Does it see him? Oh, there we go. Oh, look at that. Oh, James suggests making a big noticeable CSS change when unauthenticated. That's probably a good idea. It does have a thingy up here in the corner that says authenticated versus guest, and I guess we could change that. Oh, the control rates this thing gets are pretty interesting. So you might also notice the jitter. Some of that would be happening regardless, but I'm actually adding plus or minus 0.5 of random noise to the velocities to avoid getting stuck in just like a single truncation. So that, for example, if I'm trying to send 0.5, and instead of having to decide on 1 or 0, I can just send a 1 or a 0 half the time, and so it averages out to 0.5. So that helps. That helps especially with the drift compensation, because I need to be able to give it velocity nudges that are actually much smaller than the integer units that it's taking in right now. Yeah, I like these graphs. The encoders have a range of, I think, 4,096 counts per revolution. So it's not amazing, but it's fine. Like, so you can see the individual counts pretty clearly, but it's still a decent amount of resolution. Oh, I should scale this so you can actually see the edge of the graph. Oh, this is great. You can see the CPU temperature, the tracking cats, and the graph all at once. But yeah, I like the selection, or the suggestion to have like a big noticeable CSS change for guest. That would be nice. I should look into what the easiest way to do that is, but right now I'm just mesmerized by petting the cat and watching the graphs. It would also be nice to have graphs for the actual computer vision rectangles, just to get a sense of what they look like in the time domain. Oh, good question from Falk David in YouTube chat, who says, Rust looks cool. Is it similar to Python? Kind of looks like it in a way. It's got a little bit of the same idea behind it. I mean, you can definitely find similarities between like the module and package system in Python and in Rust, and it's got some of the same kind of modernity that you might expect from like the Python ecosystem, but it's in a systems programming language. So like I think the one that I usually find myself comparing Rust to is C++, because I would use Rust for some of the same projects I would use C++ for. But it's definitely much nicer to program in than C++, at least I find it to be. And so in this project, there's a lot of code in different languages. Like I've had some development tools in Python. The actual firmware for the microcontrollers is in C. The computer vision stuff is in mostly C++ with some C. And this cat is really fuzzy and delicious. I mean, he likes to lick me, and he seems to be okay with me licking him, so. Yeah, no, Rust is pretty great. So I'm using Rust for the server that kind of implements everything in between those extremities. So all the actual bot control loops and the HTTP and the WebSocket server behind this browser thing are in Rust. And yeah, I like Rust a lot. It's nice because it gives you a lot of the same low-level expressiveness of C++, but and then a lot of people talk about the memory safety as this thing that makes it easier to write more correct programs. But I think it's also interesting that it lets you write programs that are multi-threaded without nearly so much fuss about sort of different ways that different libraries might handle data ownership, because the compiler itself actually knows about objects being passed between threads and like when objects are allocated and destroyed, whether it's at compile time or at runtime. I think there's just this degree of interoperability where you can just expect Rust components to work together across threads, and even if you're doing, even if you're kind of asking a lot from the system in terms of concurrency and memory allocation, you can get libraries that different people wrote to work together, and so that's pretty cool. Oh, good question from Matt Druitt on the Gitter chat, who says, awesome video on the IntelliKeys, got a kick out of the driver teardown. Will we see anything around that on a stream? For sure. Yeah, I'm definitely going to be working more on that. I mean, Bill and I are planning on having more like co-streams on it where we both stream on it together, and I'll probably be working on it between now and the next one of those at least once or twice. So yeah, plan on it. Just wanted to make a little more progress on the cat robot today, but I mean, and also I just kind of want to apparently just like pet Tuco on the stream while we stare at graphs and cat sprites, because that seems to be pretty fun. Oh, good question from Ryan, who asks whether Rust's multi-threading is platform agnostic or if you still have to care about the OS. From what I've seen, it's pretty much platform agnostic. I mean, there are some platform-specific things you can get access to for sure, but like all the basic multi-threading primitives are very cross-platform, like, and everything depends on them. So you can, I mean, you can make a really complicated multi-threading message passing application. Like, I mean, pretty much everything here is cross-platform. There are some libraries I use that have separate code for each platform. So for example, joystick input, it's going to be separate on all the platforms. But I think the one I'm using supports Windows, Mac, and Linux. So yeah, I mean, the Rust code should be pretty portable. I've been running it on Windows so far because it seems convenient to run it on the same machine as everything else here, and to not just need like a separate machine, which then becomes part of the same dependency chain. So. And Rust also has a lot of different, yeah, so Ryan's mentioning Python's concurrent .futures. There's also a pretty thriving ecosystem around sort of futures-based concurrency in Rust. And so you can find that. There's a I/O framework called Tokio, Tokio, and that's actually what the WebSockets server that I'm using is built around. But that, like it can make your code quite a lot more complicated than just straightforward threading, and so a lot of stuff in Rust still comes in both flavors, and the language itself and the runtime aren't really opinionated about doing your I/O in synchronous versus asynchronous ways. You can find pretty powerful multi-threading primitives, but the language also lets you build really powerful futures on top of that, and there are some really popular crates that do exactly that. And of course you can use futures and threads. It's just a lot of times when people use a powerful futures model, that's an excuse to put a lot more stuff on single threads, which can also be nice sometimes. My coffee's empty. Oh, and the CPU is pretty warm. It hasn't hit 90 well, I guess it has hit 90. I don't know when these maxes get reset. Is that something I can do here? Yes. Apparently it's fluctuating a lot. Anyway, someone was asking for like a before and after thermal camera imaging, which I guess I could do, but like the machine is in the rack right now. I would have to take it out of the rack, and getting it to run all these same workloads outside the rack would just mean running a bunch of extension cables to all the video inputs. But it's a thing I could do, but I'm not extremely motivated to do it, because I'm not like a overclocker channel. I'm just trying to use this machine to get some work done. Anyway, what's next on our list? I guess we still haven't decided about the limiter. Well, the CPU is running pretty hot, and I could use a sandwich, so I could just make this a short stream and work on some of the code off camera, but it was at least nice to be able to show the cat sprites. I'm having way too much fun with these. But $80, $87. Yeah, I don't think these processors like running that hot. I mean, I'm pretty sure these will automatically throttle once you get to a certain temperature, but I don't think we're there yet. These look like relatively normal max clock rates. Oh, the GPU is definitely spiking up to 100% for brief periods and however long they measure this. But this, I think this, well, so this is actually power consumption, I guess. I think this is current power consumption divided by total dissipation profile. Because I went and looked at various GPU performance metrics to try to see, well, how hard is the GPU working right now? Which is a difficult question to answer because you're going to be using some mixture of general purpose and special purpose parts of the GPU, and then your workload is going to have a mixture of actually working versus waiting for stuff to get done. But one metric that this might be using, well, so this is going to be power versus total dissipation profile. Another metric that I think Windows uses was based on the percentage of time that the GPU is idle, so like you would do with a CPU. It's just that, like with CPUs, we assume the performance is homogeneous enough that like we're not going to cry over, oh well, your CPU is 100% utilized, but actually your floating point unit is totally idle, and so you don't see tools that give you that level of detail. But that's kind of what I'm asking for the GPU, like, oh, your GPU is 100% utilized because you're rendering rectangles all the time, but your, you know, video encoder units are idle and your shader units are not working very hard, you know. And so that kind of tool is more specialized, and you can get debug information like that if you like run a program. I think NVIDIA has this Insight HUD that you can use for that, and there's like some Visual Studio plugins. There's like an OpenGL, there's a couple of good OpenGL debuggers that will give you that kind of detail, but like that's not something you just get passively in System Tray these days. Let me see if I can at least point the thermal camera at the back of the rack-mounted machine while this is running, because maybe that would be entertaining. Oh, interesting. James in chat says Intel doesn't give useful metrics for how hot your CPU is allowed to be. Interesting. And then they give metrics for the max temperature at the top of the package, but then you don't actually have a measurement there. That's like if you're doing characterization and you can put a thermocouple there, great, but I don't have a thermocouple there right now. I'm going to take my chances with this FLIR camera and see if I can get that working. Yeah, so a lot of stuff is running on the CPU right now, which is partly why it's running pretty warm. I mean, OBS seems like it is not especially light on the CPU to begin with, but so I think there's just like a lot of background noise in terms of like OBS and Ableton, just like, and I've got 2 copies of OBS, and so there's going to be like a bunch of random stuff running. But the actual CPU hogs in this case are going to be the computer vision code. And so the object detector, I think is, I mean, it's going to be running almost entirely on the GPU, but I think there's still a decent amount of CPU overhead in just keeping the GPU fed. So that might be an area for improvement. And then the tracker is running entirely on the CPU, and it's hungry. I mean, I'm assuming that one core is probably going to have to spend like 40 or 50% of its time at the very least running the object tracker, probably more like 60 or 80%. This thing is not very reliable. Oh, is it coming up? Yeah. Now let's see if I can share my screen. Alright, I don't think I'm going to bother with the wireless mic, so I won't really be able to talk, but I'm just going to stick this in the rack and we'll take a look at the machine. There are going to be 2 4U machines at the bottom of the rack, and then a UPS. So the thing at the very bottom is not a computer, it's just a UPS. And then there are 2 pretty tall machines. The one at the bottom is my workstation, which shouldn't be doing much right now. And then the one at the top is going to be this machine, which is probably going to be kind of warm. Welcome back. So yeah, it's kind of warm. Not like worryingly so on the outside, but the CPU certainly is toasty. Oh wow. T-junction max at 100C for my model apparently. So yeah, I mean I guess I'm not getting close to the point where it's gonna throttle, but it'll it'll certainly not be the happiest running this hot. Oh yeah, and then I can't quite see the name, but somebody says neat how you can see the LCD backlight. Yeah, all the screens you can see pretty nicely. The little LCDs in like that fan controller in the case, or in the rack. The LCD monitors are pretty warm. Like, there's my filming area. Oh, I guess you mean you can see which side of the monitor the backlight is on. Yeah. That's really nice. This one is just warm all over, but I guess the backlight's probably at the top. James says, what's the topmost thing? That's a monitor. The structure is actually... That's coming from the visible camera. So, hello, Drosty effect. There's my microscope. Tuco knows how to warm up this whole chair. Alright. Well, I think maybe this is a good time to sign off and get myself a sandwich and write some code and let my computer cool off, and then maybe I'll have time to do another stream later today after I get the fan installed. But I wanted to at least show off the recent improvements in the tracker because I'm pretty happy with the direction this is going in. I thought some of you might be interested too. Vince says all you need now is some snow so you can appreciate all the heat being produced. Yeah, right? I mean, the heat doesn't go to waste right now because I need to heat the shop anyway right now for the most part. We've exited completely summer. We have entered somewhat winter-like as far as the seasons go. But, I mean, it's still a situation where like I've got to have fans in the rack to keep the stuff in there cool, otherwise the heat builds up. Yeah, a bagel would be amazing. I should just go get a bagel sandwich and write some code. There's a place, like just right on this block, which can give me a bagel in exchange for shiny American currency. So I might go do something like that. It would be nice to graph the computer vision rectangle, wouldn't it? I could do that entirely in the JavaScript side. I wouldn't even need the Rust changes because it's already getting those rectangles. It just needs to store it in the model and then add some graphs to the model. Yeah, this combination is pretty nice. I really like the Rust backend plus this kind of React app front end. And the whole architecture here is based on this shared message bus that a bunch of different clients all get to snoop in on. And so the main message bus client, which is also the only message bus sender, is the kind of robot control loop, which is just like the center of this whole thing. But then there are peripherals stuck on all over the place, like the computer vision algorithms in this web browser. So, all right, folks, I'm gonna get a bagel and let the computer cool off, but I hope you appreciated the short stream here, and I'll try to do another one a little bit later once I get the computer refitted with some cooling and get a little bit more code written. Thanks for stopping by, folks.